function of a fluid flow is given by 2xy, then find out the magnitude of the velocity vector at 2 comma minus 2. Here the options are 4, minus 4, 4 root 2 and minus 4 root 2. So here the given function is stream function. For this, the velocity in x direction is given by dou psi by dou y of a negative sign. So here it is equal to minus 2y, and velocity in y direction is given by dou psi by dou x, and which is equal to 2x, where psi is the stream function and is equal to 2xy. So here at the point 2 comma minus 2, u is given by minus 2 into minus 2, which is equal to 4, and v is equal to 2 into minus 2, which is equal to minus 4. Sorry, 2 into, sorry, it is minus 2x and it is 2y. So that here minus 2 into x is 2, so that it is minus 4, and here 2 into y is minus 2, and here it is equal to minus 4. So the velocity vector at this point is equal to minus 4 whole square plus minus 4 whole square, which gives a value of 4 root 2. So the correct answer is 4 root 2 in the option. The correct option is C. C is the right answer. TdS is equal to du plus pdv holds good for. Here the options are any process undergone by any system, any process undergone by closed system, reversible process undergone by any system, reversible process undergone by closed system. So here we know that for a closed system, the equation is given by dq is equal to du plus dw or du plus pdv, and also dq can be represented by TdS for any process. So that by using these two equations, TdS is equal to du plus pdv holds good for any process undergone by closed system. So the correct option is B. B is the right answer. A gas turbine power plant has a specific output of 325 kJ per kg and an efficiency of 32%. A regenerator installed and the efficiency increases to 44%. The specific output after regeneration is, here the options are 325, 347, 309 kJ per kg, sorry 389 kJ per kg, and D is we can't say. Here before installation of regenerator, the efficiency of the power plant is 32%. After installation of regenerator, the power plant efficiency increases to 44%. But the purpose of regenerator is to reduce the heat input to the heat input, but not to increase the specific output of the turbine. So that here regenerator doesn't affect on the specific output, so that the specific output remains same, but the heat supplied to the power plant will be reduced. So that's why the efficiency will be increased to some extent, but it doesn't affect on the specific work output, so that the specific work output remains same and is equal to 325 kJ per kg. And in the option, the right option is A. There's a cooling tower at a temperature of 15 degrees centigrade and 101 kilopascal pressure with a volume flow rate of 20 meter cube per second. Specific humidity of air at inlet and outlet of the tower are 6 into 10 power minus 3 and 0.3 respectively. Mass flow rate of air through the tower is, here the options are 10 kg per second, 24.4, 36.6 and 42.1. Here the air is nothing but we can assume it as perfect gas. So here consider the initial conditions, that is temperature 15 degrees centigrade, pressure 101 kilopascal, volume flow rate 20 meter cube per second. So by applying perfect gas law, PV is equal to MRT. From this equation, we can get the mass flow rate is equal to PV by RT. So consider all the initial conditions, so that we know we have the known values of P, V and T, and R also we can assume it as 0.287 kilojoule per kg Kelvin or 287 joule per kg Kelvin. So which gives here 101 into 10 cube, and volume flow rate is 20, and here R is 287, where the temperature is 288 Kelvin. It gives a value of 24.4 kg per second, and in the option the correct option is B. B is the right answer. Our assumptions during the derivation of steady flow energy equation. Here the options are flow is steady, flow is inviscid and incompressible, no shaft work and heat transfer in the control volume. Here select the correct answer by using the codes given below. Here it is a general steady flow energy equation. It can be used for either compressible or incompressible, and of course it includes some heat transfer and shaft work also. So that the assumptions 2 and 3 are wrong. The assumption is 2 is inviscid and incompressible, but it can be useful for compressible flows also. So that the second assumption is wrong, and third assumption is no shaft work and heat transfer in the control volume. But in general steady flow energy equation, there is a heat transfer and there is some shaft work also. But when it comes to the Bernoulli's equation, all the assumptions are right. But when it comes to the steady flow energy equation, it is these two are wrong, and the correct assumption is flow is steady. So in the option, the correct option is B. B is the right answer. 2.5 kg of fluid with 2.5 kJ per kg Kelvin specific heat subjected to stirring process in an insulated chamber. The temperature of the system rises by 15 degrees centigrade. The internal energy change of the system is, here the options are 562.5 kJ, 56.25 kJ, 0.5625 kJ, and 0. Here the change in internal energy of the system is equal to mcv delta t, where m is the mass of the fluid and cv is the specific heat of the fluid, and delta t is the change in temperature. Here temperature of the system rises by 15 degrees centigrade. That means the change in temperature is equal to 15. So which is equal to 1.5 into 2.5 into 15, which gives a value of 56.25 kilojoules. So in the option, the correct option is B. B is the right answer. For manufacturing slip gauges is, here the options are high carbon steel, high speed steel, low carbon steel, low speed steel. So here generally for the slip gauges, the high carbon steel is used to measure immediate duration of times for an activity in the PET network under the worst and best environment are given as 9 and 3 days. The variance of this activity is, here the variance for an activity is given as the best and the worst condition. The difference between the best and worst condition, that is 9 minus 3 by 6 whole square, which is equal to 1. So here the right answer is 1, and in the option the correct option is B.